In this video, we are going to solve problem 13-15 that is taken from chapter number 13, Buckling of Columns, and book name is Mechanics of Material by RC Hibbeler, 9th edition. So statement is an A992 steel W200 by 46 column of length 9 meter is pinned at both of its ends. Determine the allowable axial load the column can support if factor of safety is to be used against buckling. So you can see we will have W200 by 46 column of length L, and we will find the allowable axial load with a factor safety of 2. So let's start with the solution. As we know that critical load, which is the maximum load, is represented as pi square EI divided by LE square, where what is LE? So LE is effective length and it is equal to K multiplied by L. Now what is K? So K is given that both ends are pinned. So we'll find the K from the book. So you can see here in book you have this condition that is shown pin ends. So here K is equal to 1. So I will write K will be equal to 1 multiplied by effective length, which is equal to 9 meter. So LE effective length will be equal to 9 meter. Now what is the value of E? So you can see it is A992 steel. So again you have to go to the book at the end. Let me show you at the end in the average mechanical property table using SI units. So we will locate A992 steel, and again you can see it is already highlighted. A992 steel having modulus of elasticity is 200 gigapascal and yield strength is 345 megapascal. So I will write these two. E is 200 gigapascal. So 200 into 10 to the power 9 pascal, and yield stress is equal to 345, and the unit is megapascal. Now what is the value of I? So we will find this I. We will check both IX and IY of this AW200 columns, and we will take its value from the table, as well as we will also need the area later on. So we will take all these three values from the book. So again you have to go to the book and you will have to move the appendices. So you can see here appendices, you have to go to the geometric property of steel and SI units. So you can see these are in FPS, foot pound system. So you have to go to the SI unit and you have to locate W200 by 40. So now you can see in the first column you have this W200. So W200 by, let me check it, W200 by 46 was the column. So W200 by 46. So on this row, what you have to pick is that you have to first select this area, the value of this area. You have to check this IX, which is this, and IY, this one. So I will write it. IX is 45.5 into 10 to the power 6 millimeter power 4. 45.5 into 10 to the power 6 millimeter power 4, and IY was how much? 45.5, and this is 15.3. So IY is 15.3 into 10 to the power minus 10 to the power 6 millimeter power 4. So this was, what was IX? IX is 45.5. So let me correct it. This is 45.5. And what is the value of area? So area is how much? 5890 millimeter square. 5890 millimeter square. Okay, now I will write it that if you have column with a load given, so buckling occurs only in the direction are about axis having less moment of inertia. So from Ix and Iy, we have Iy is less than Ix, so buckling will occur in about y-axis, occur about y-axis. So we will take the moment of inertia Iy will be equal to 15.3 into 10 raised to the power 6 millimeter power 4. We will convert it into meters. So 15.3 into 10 raised to the power 6, and you remove milli. So milli is 10 raised to the power minus 3, power 4 is 10 raised to the power minus 12, and it will be millimeter power 4. So what I get will be equal to 15.3 into 10 raised to the power minus 6 meter power 4. Now you have the value of Iy as well. So just plug it in this formula. I will write it over here. P critical is equal to pi square E is 200 into 10 raised to the power 9 Pascal, and I is Iy, which is 15.3 into 10 raised to the power minus 6 divided by LE. LE is 9, so 9 square. Now we'll calculate this. So 3.1417 square multiply by 200 multiply by 10 power 9 multiply by 15.3 into 10 power minus 6. This is the upper value in numerator, divide by 9 square, which is equal to 3 P critical comes out to be 372,877.202, and if you divide it by 1000, so it will be equal to 372.8 kilonewton. So this is the value of critical load. Okay, now we have been asked determine the allowable axial load with a factor of safety that can be used. So we know that factor of safety is equal to P critical divided by P allowable or P applied. Let me write it as P applied. So from here P applied will be equal to P critical divided by factor of safety. So just plug in the value 372.8 divided by 2 is P applied, clear, against the buckling. So 372.8 divided by 2 is 186.4. So I can write it as P applied, or a maximum load against this factor of safety comes out to be 186.4 kilonewton, or if you round it off, so P applied will be equal to 186 kilonewton. And this is the answer of our this question. Now if you want to check whether this critical or this critical load causing the stress, which is critical stress, it should be less than the yield stress. So we can write this P critical divided by area, it should be less than the yield stress. Okay, so what we are going to do is that you have critical load, which is 372.8 kilonewton, divided by area, which we have taken 5890. So 5890 into 10 raised to the power minus 6 square meter, and that will be, this area will be equal to 5.890 into 10 raised to the power minus 3 square meter, because we will need the units in meter. So I can write it 5890 into 10 raised to the power minus 3. It should be less than the yield strength. So let me calculate 372.85. It is in Newton, kilonewton. So we will multiply by 10 raised to the power 3 to convert it into Newton, divide by area, which was 5.89 into 10 raised to the power minus 3. So sorry. Okay, so you can see this is 63 if you divide it by 10 raised to power 6, so it will be 63.30 megapascal. So I can write it again. There is 10 raised to power, so 63.3 megapascal, and it should be less than the yield stress. So yield stress, you can see, let me show you where I have written yield stress is 345 megapascal. So it means that our answer is 186 is correct, and Euler formula is valid. So this was all about this problem 13-5. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.